All right. All right. Good morning, everyone. Thank you so much for joining us this morning. My name is Naomi Newman. I'm with 3C Ren, and I've just started recording this course, which will be posted onto 3C Ren's on-demand page. Today we have Jennifer Rennick and Tatia Soglin from Imbalance Green Consulting, and they're going to talk about energy code implementation for multifamily buildings. And before I turn it over to them, I just have a few slides to run through. So you can go to the next slide, please. So just a quick reminder, we ask that you make sure you're on mute throughout the duration of the course. And if you would like to verbally participate, please raise your hand and we will call on you to unmute yourself. And we encourage participants to ask questions. So please use the chat box throughout the course and we can answer some of those questions. And a few words about who we are. 3C Ren, aka the Tri-County Regional Energy Network, is a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. And we work to improve energy efficiency in our region by offering free programs and services for building professionals and households. It's funded by taxpayer dollars, which are collected through the public goods charge found on our utility bills. And the benefit of this is that it's ratepayer funded, so there's no cost to those who we serve, and we can return these dollars back to our local economy. We have 3 different programs. So we first offer the Energy Coach service and the Energy Code Connect program, which is an over-the-phone, online, and in-field support for Title 24, Part 6, and Part 11 related questions for both residential and non-residential projects. And we also offer online courses and regional forums that are designed to increase overall energy code comprehension, compliance, and enforcement. Our next one is the Building Performance Training Program, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles and high-tech performance buildings. And lastly, we have our Home Energy Savings Program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Jennifer, who can introduce today's course and get started.
Thank you. Hi, everyone. Thanks for joining us. And I am here with Tatiana, who's also works in our office. She's going to monitor the chat. So feel free to put your put questions, comments in the chat, and she'll stop me as we go along. And we'll hopefully have a little bit of time for questions, answers towards the end. But if there's something pressing, feel free to jump in. This is part of an energy code series that we're doing with 3C Ren. And today we're looking at multifamily projects. And I want to remind folks that we're located on the California coastal climates. We're mostly talking about Ventura, Santa Barbara, and San Luis Obispo counties and those climate zones. We have learning objectives. So if you're an architect and need AIA units, or building official need ICC CEU units, contact Naomi. And today we're going to talk about the 2022 Energy Code. We're going to have a quick overview. Then we're going to review a couple of the mandatory measures that we see coming up a lot in the Code Coach and in our practice. We're going to hit on some of the prescriptive and performance measures. Again, some of the main ones that we're seeing show up as questions or architects are reaching out to us to know more about. So it includes a little bit of the updates on the envelope, hot water, and what kind of systems they should be looking at or could look at. They're not, architects aren't too sure what they should be looking at for space allocation, depending on the system. So, okay, let me pause here for a second. I am definitely coming at this as both like an energy consultant, but also as an architect. So jump in if I miss something that you have a question about. And so solar and battery, again, a little bit more of the perspective from an architect. And then we're going to, at the very end, kind of hit on additions and alterations and just touch on a few of those topics. It's nuanced, so we're not going to be able to get into additions and alterations in any depth. It's kind of big picture overview. Just a reminder, the California Energy Commission updates the energy code every 3 years, and we now have the 2022 code in place. And as a lot of you know, we're gearing up for understanding more about what's coming up for the 2025 code already. And the big picture goals for the 2022 code update was to encourage more heat pump technology for space and water heating and establish electric ready requirements for the single family and multifamily projects. And of course, we're expanding our PV or solar systems, battery storage standards, and strengthening our ventilation standards. So one big change for multifamily, if you're not familiar with how the energy code is organized, under the previous code cycles, we had mandatory measures that, and all buildings were addressed. We had high rise and non-residential hotel motel together, and then low rise residential sections. Okay, under the new 22 code, it got mixed up a little bit in the sense of, I mean, mix it up in a positive way. So now we have all buildings in sections 100, section 100, 110, non-residential hotel motel sections. Those numbers, chapters haven't changed, but the high rise is taken out from it. We still have our single family residential section, but the multifamily low rise was taken out of it. And now we have new sections dedicated to multifamily buildings. And for some of those kind of high level changes on the multifamily is that there's been some dwelling unit ventilation updates, some domestic hot water requirements are a little bit different, space conditioning requirements. The baseline has changed a little bit, and we have electric ready and photovoltaics and batteries now. It's a requirement for the high-rise residential, but we'll go into that in a little bit more detail. There's also 2 metrics, TDV, that continues to be a metric that we use, and we have also a source energy. So if you have been looking at your single family projects and seen a source energy, that also is showing up for our multifamily projects now. So a couple terms, just as we go through this as a reminder for folks. Mandatory requirements, they're applicable to everything. Performance method is our energy modeling approach. This is an approach where you can have trade-offs and credits, but the prescriptive component package, you have to follow it like a checklist, like a recipe card. You can't do trade-offs, but it's used to inform our standard design or our baseline design for that performance method. The other kind of thing that's just come into play again for our low-rise residential permitting is, you might recall in codes past, low-rise residential had to be enrolled on a HERS registry. And that is in place again for our low-rise residential. So remember, this whole new chapter, it's low-rise and high-rise kind of put together. So you're going to hear me talk about, well, this thing is true for low-rise, but it's different for high-rise. So you're in your mind, kind of remember that low-rise is 3 stories or less habitable stories, and high-rise 4 stories or more. And so a lot of what we're going to discuss has this differentiation, even though all multifamilies kind of put together in a section, in a whole chapter. So the forms are a little bit different now for low-rise residential, and they are designated as LMCC as opposed to like CF1R for the single family, or what we used to use for multifamily. So at the design submittal phase, that Title 24 compliance form would be uploaded to your HERS registry. And then during construction, you would have the next set of forms, the LMCI for installation and LMCV for verification by your HERS rater, and they would upload those to the HERS registry. And then your building official is going to confirm that those forms have been uploaded and signed. And right now we have two HERS providers, CalCerts and Cheers. So what that might look like for a new low-rise multifamily residence on CalCerts is they're going to ask you for the project type. And it used to be that you would just choose that you're going to upload your CF1R, but now you'll want to upload your LMCC, and that's under 2022 code. So the other multifamily forms are not an option under the 2022 code. So just, it's a little different on that. And the registry was not open when the 2022 code first came out, but as of February, the HERS registry is now open. And so all your multifamily, low-rise multifamily projects are supposed to be registered on CalCerts if they're requiring those HERS measures. Another reminder, mixed occupancies, which is typical of a lot of the multifamily projects, especially multifamily high-rise, is that each occupancy type, so the residential and the non-residential, would each comply with Title 24 Energy Code specifically, but there will be cases, and as a reminder, there's a couple of exceptions, and we call it the 80% rule, sometimes in the 90% rule, and it means essentially that you could model those common spaces as part of, for example, in a low-rise residential project, you could model those common spaces all as low-rise residential, as long as your 80% of the project, of the conditioned floor area, is residential, and then you meet the mandatory requirements and the lighting requirements for those other occupancies. And what that looks like now in terms of compliance with a new metric is when you get that Title 24 report from your energy consultant, you're going to be looking, and your energy consultant will also be looking at this, that the building complies with three metrics: an efficiency metric, which is the TDV, and then the total TDV, which includes those solar and batteries, if batteries are required or you're taking as a credit, and then the source energy, which is kind of used as a proxy for carbon. So what that might look like is your source energy is a carbon, new construction carbon proxy. You got that metric, and then you have TDV, which continues to be the metric for, we've had that in place for a while for all the high-rise residential and the non-residential. And TDV stands for time-dependent valuation, which we can circle back on that one if you have questions. But I think the main thing here is to realize now with the low-rise multifamily is it's now pulled into this new category. So it's going back to the TDV metric just when you thought you got used to the EDR metric from the last code. Okay, so a couple of the main mandatory measures. that we're going to hit on now is indoor air quality and electric ready. But before we do that, since these are brand new sections, I just wanted to show folks what the new multifamily section 160 looks like. And it addresses the mandatory requirements for your building envelope, ventilation and indoor air quality, or IAQ, space conditioning systems, water heating systems, lighting, electric power distribution. So that's kind of pulled in from the non-res part of the code of the last cycle. Covered processes, that's kind of pulled in from the non-res of the last cycle. And then solar ready requirements hasn't really changed much. And then now some new electric ready requirements. And this part of the code now is applying to the dwelling units and the common use areas. And then the truly non-residential occupancies in a mixed occupancy building still need to comply with the non-residential sections of sections 120 through 141.1. For IAQ for multifamilies, since we're dealing with residential space and sort of the common space or non-residential space, we still are saying the attached dwelling units, they're going to follow that residential code, and HERS verification diagnostic testing for those 3 habitable stories or less, that's low rise, are still applicable. And then the spaces other than the attached dwelling units are going to follow the non-res part of the code. And so in some instances, you could have HERS, but you may also have ATT or, sorry, I just drew a blank for our acronym, but the ATT tester can also, you'll see a form that addresses that, and then they can take a look at that for your high-rise residential projects. And just kind of a reminder that townhouses or duplexes are still considered single family. Those aren't multifamily. If your project just has 1 lot, 2 attached units, that's a single family. So the requirements for ventilation and indoor air quality, ASHRAE 62.2 continues to be the basis for the dwelling units. ASHRAE 62.1 continues to be the basis for the common areas. And now they've added some language to kind of clarify a little bit about if you have a central fan for your ventilation system. There's some prescriptive ventilation duct sizing for your kitchen and kitchen exhaust. And there's now language that it specifically addresses balanced ventilation with heat recovery and required testing of ventilation airflow. We're going to just touch on that briefly. But I put this slide in here for the ventilation for indoor air quality for folks who would like to get an estimate, especially the architects, to get an estimate for how much ventilation is going to be required for your dwelling unit. And you will get a copy of these slides. So if you do the performance method or include infiltration, this number might be slightly different, but this gives you a really good idea and a good place to start and understanding what those requirements are going to be. And we're seeing that this comes into play a lot on the multifamily projects we are modeling, where projects sometimes are over-ventilated and you can't be more than 20% out of what you need for this. And some projects, some architects are under-ventilating them. Usually your mechanical engineer picks that up, however. So from the architect's perspective, and when you work with your mechanical engineer, And even when you start thinking it through with the builder and your HERS rater, is you will want to consider whether it's worth it to have your projects be ventilated through local bathroom exhaust, which tends to be so common, or a supply only system, or a balance system, and whether that balance system includes ERV or energy recovery ventilation or heat recovery ventilation. So in addition to those concerns, your kitchens and bathrooms still need local mechanical exhaust. And there are certain requirements now for the kitchen, depending on whether your kitchen's enclosed or whether it's open to the system. And still, all these fan systems, if they're part of the IAQ ventilation, they do need to be tagged in the sense of some way of identifying at the switch that these can be turned on and off, and they can be turned off if the outdoor air quality is very poor. But otherwise, the idea is that your IAQ ventilation system would be left on the whole time. And so for kitchens, this is new to the code. It really, what we've learned through the EPA and some of the studies done out of NREL is that pollutants from cooking are more concentrated in smaller dwellings. And so the smaller the apartment, the more ventilation you need. So for example, if you had an apartment that's 800 square feet, you would need a kitchen exhaust fan that's 130 CFM or is 55% capture efficiency rated. And for smaller units, the ventilation goes up. Also, if you're cooking over natural gas and your particular project you're working on, the ownership decides they really would rather have natural gas run up through each apartment, then the amount of ventilation increases quite a bit. So for that same size apartment, you'd need 280 CFM. Personally, most all the projects we work on, we're seeing that no matter what, the kitchens are going electric anyway. It seems to be more cost effective. So we're often just looking for these ventilation hoods that meet this new requirement.
Jennifer, can I jump in really quick with a question?
Yes.
We have a question from Ben asking if a mixed-use building is non-res on floor 1 and multifamily residential on floors 2 through 4, does that make the residential portion high-rise since the building is 4 stories, or low-rise because the residential portion is only 3 stories?
It's by habitable stories. So if that bottom floor is habitable, occupiable, not a parking garage, then now the whole building is going to be the 4 stories or more part of the project. But there's also these other things we'll hit on it. It's under 10 stories, so then some other things will come into play. So it's a little bit of a blend. But if anything in the code, once you dig into it, if it's not straightforward, you reach out to us through the code coach, and we'll work with you to help you figure that out.
Thanks.
Thank you. And on the for those kitchen and bathroom mechanical exhaust in this section, there's been under the mandatory measure, there's a change. And so now, just kind of FYI, if you want to comply with this exhaust system prescriptively as a mandatory measure, then now they're explicitly saying total duct length needs to be less than 25 feet, no more than 3 elbows, and have some, termination fitting with a hydraulic diameter that's proportional to the minimum duct diameter, etc. And you could find more about that in the code, or you could have someone come out and do the airflow testing and show that it meets the CFM that you want. And so one of the HERS raters that is part of the 3C REN that we've done some of the courses with, he's often in his practice going out and testing hoods just for this reason, when you can't meet that sort of prescriptive requirement. And there is the hardworking HERS rater here in front of a multifamily project we were working on. So part of this is that low-rise multifamily is going to require the indoor air quality and mechanical ventilation testing. And there's a similar form for high-rise, but these forms, the LMCI and the LMCVs, they very much follow what was the CF1Rs and CF2Rs of the old style of forms under the previous code. And some of the big difference, though, from those single family is that there's language that include backdraft dampers and air sealing to stop air movement between dwelling units. And so what we're finding for some of our architects and even some of the engineers is that if you take a closer look at these forms, which you can get through the CEC website, is they will kind of give you that language that you can include on your plans that will be required, so that there aren't any big surprises for the builder, because they will be needing to work with a HERS rater for the indoor air quality requirements. And then for our balanced ventilation systems, not everyone is familiar with these, so I wanted to show you a diagram of a type of heat recovery ventilator or an energy recovery ventilator. And they're essentially a box. There's many brands available right now. And you could go on to the Home and Heating Ventilation Institute website and get a list of all the brands that are qualified. But basically, outdoor air through a duct is pulled in and it's passed through the special multi-channeled membrane filter, and the heat and sometimes moisture, if it's a ERV, is transferred to the outgoing air. And that way, when the incoming air comes into the house or to the apartment, it's tempered. And so that can, for certain climate zones, be an energy savings, and you can take credit for that on your performance calculations. And what that could look like is it could be a more expensive system like this Zender, which for a large flat or even single family homes, you could have small ducts running throughout the home and provide that fresh air in a balanced way. Or in this case, if you're doing it for an individual dwelling unit, you can have a smaller system, same concept. And then there are now requirements for fan efficacy for how much watts, 1 watt per CFM, that you're allowed to have, depending on what's happening with your system. So here again, this is a good way to just kind of jump into what the code requires. If you're not going to dig into the code itself, you can go to these forms. And what this basically means, though, from the builder's perspective and the multifamily ownership's perspective in your HERS rater is if you do balanced ventilation, that HERS rater will not have to go through the elaborate testing for compartmentalization to show that each apartment is not sharing air and that with each other, and that each apartment is properly balanced so that you have an equilibrium across that system. So the balanced ventilation we're finding for a lot of our projects is cost effective. And so the photo on the left is from a multifamily project we worked on, and this is where they put the Renew Air with its ducts behind a little closet near the entry, and seemed to be a good location. And you do need to be able to access it so that you can change that filter, clean it out as depending on the type and the brand. And then for the high-rise dwelling units, the HERS or the ATT acceptance testing technician. We also have the IAQ ventilation requirements, but these forms look a little bit different. You're going to find them under the non-res section, the NRCA part of those forms, and they're going to talk about functional testing like you would for a lot of non-res projects. But same kind of idea, and it talks about if it's balanced and what you're allowed to have for testing and your fan watts per CFM. Under the mandatory measures, we also have a mandatory measure that addresses the water heater and electric ready. Two different sections, but the ideas, they're all about how to be electric ready if the ownership decides to install gas for either their water heater, their furnace for space heating, the cooktops, dryers in the individual dwelling units, or dryers in the common space. And so if gas is installed in any of these locations, you have to include and install the complementary electric system and have it be ready for future for a future electric item. And that includes making sure there's a conduit for it, outlets, and space in the dwelling subpanel. And what that looks like, I put this in here. California Energy Commission, they're trying to do a lot more help on the website. And so I thought this was a great excerpt from what they were showing, what this translates to. Say, for example, you're going to have a common laundry space and the ownership is contracting with a third party for the equipment, and they decided that it makes the most sense to have gas dryers. They're allowed to do that by code, but then you need to provide everything to be electric ready. And the raceway, the panels, the switchboard, the bus bar, everything has to be rated to be able to take care of the future electric dryers. And also part of this is just part of the plumbing code, is that gas flow rates all were determined by plumbing code. That still has to be done. Okay, now we're going to jump into some new construction prescriptive and performance items that we've noticed that come up a lot in the code coach questions, or just kind of come up in some of the projects we've worked on. And again, to give you a sense about this is a new section. 170.0 is sort of that multifamily section. And then it's broken into the point 1 is your performance approach. Point 2 is your prescriptive approach. It does apply to the dwellings and the common spaces. And then, you know, your truly non-residential occupancies would need to comply with the non-res part of the code. So it hits on building envelope, daylighting, space conditioning, water heating, lighting, photovoltaics for 3 stories or less, photovoltaics 4 stories or more, and battery storage systems. I'm going to hit on a little bit of the envelope, some of the water heating, and then the PVs and batteries. I'm going to hit on this with the envelope. A lot of it, big picture, is there really hasn't been that many changes between the 2019 and now the 2022 code. But what I want to point out is if you're looking into the code, the structure of it's a little different with how you look things up in these prescriptive tables. And so I'm going to run through some of those things on the table for the envelope. Then basically the way you use these charts is you're going to look at option B. It means it's an attic and ducts are in the attic. But if it's option C, it means it's an attic, but your ducts are in conditioned space, which is something we look at a lot because you get a good credit for that. Or the option D means it's a non-attic roof, and then it has some slightly different requirements. And so what this looks like now is kind of same tables, values from before, but kind of repackaged, whether it's option B. So you've got options for ceiling insulation at the ceiling and below the roof deck. But again, the ducts are in the attic. And even if you're not complying with your project prescriptively, I point this out, you'll get a copy of it, is that by climate zone, you're going to be compared to these values in your prescriptive modeling. And so it's not a big surprise, like climate zone 5 here in San Luis Obispo, the ceiling insulation is an R30, a radiant barrier is required, and there's no under deck insulation requirement. It's pretty straightforward. It's really similar to what it was in the past, just packaged a little differently. And then if you don't have ducts in the attic because they're in the conditioned space, you only have to be concerned with ceiling insulation. But again, for a lot of the milder climates for our tri-county region, it still means an R30 ceiling for climate zone 5 and the radiant barrier. So that part doesn't change too much for us for the mild climates, but having our ducts in conditioned space will give us some credit under the performance method. And then a little bit different, just kind of FYI, if you are looking this up for the non-attic roof to get a handle on what you can do, it's going to be expressed as a U factor now, instead of telling you what insulation you need for the type of framing. And it's going to vary whether it's low sloped roof or steep sloped roof. So this part of the code, it really kind of follows the kind of the commercial side of it, where it's now giving you U factors instead of the R value. So you would, if you need help figuring out what these U factors translate into, you can use our Code Coach service, and you can also go to the joint appendices and look it up, what it translates into. Wall insulation, again, I just want to point out, it hasn't changed a whole lot, but they've added this new section for metal building with any kind of fire rating, and then framed if it's wood, metal, and others that have a 1 hour fire rating. And then they've also added a section for heavy mass, and these also are expressed as U factors. And so what we're finding is for us, even for some of our milder climate zones on our multifamily projects, that point 0.065 U factor on these is translating to like a 2x6 with an R20 fill, but an R2 continuous exterior. So you can, under the performance method, trade away from it. So we're seeing that a lot of our clients are going to the performance method in order to trade away from it. But we recently had one where they did all prescriptive, and they're going to do an R2 continuous insulation product around the whole multifamily building just to comply prescriptively for climate zone 6. Soffits insulation, it varies by floor. So there hasn't been too much changed other than they added a new category called other. And if it's not a raised mass floor or wood frame floor or a slab on grade, 3 stories or less, then it's other. And then you would look up that U factor by climate zone. Okay, quality insulation installation. It's there really isn't a change from 2019. And it still does not apply to the multifamily buildings 4 stories or more. So like Ben's question, you don't have to worry about QII, but there would be best practices, you know, from the architect might still want to put some of these things on their plans, because technically the installers are supposed to be installing all the insulation to meet the manufacturer's requirements or recommendations, and air sealing is still part of the whole process for high-rise residential and required, even though QII, meaning a HERS rater coming out to look at the quality insulation installation product, won't happen or need to happen. There's one exception to this, and that's climate zone 7, which is down by LA area. So QII for the low rise isn't required. And I put this in here just to give you a little bit of an idea of what we're talking about when we talk about QII and insulation types. And apparently, when I showed these photos from some jobs we were at to Paul, our HERS rater, he said, yeah, these would all fail. And what he specifically pointed out was cases where insulation might be undersized or it's compressed and squeezed so that it creates a lot of voids. And generally, when this happens, the actual R value you get from these products just bottoms out. So ideally, you could, as an architect, you could specify blown-in products like blown-in cellulose or blown-in fiberglass like signoff, and you would make your QII very easy. And the other thing is, work with the ownership and maybe put that on your plans that QII is mandatory, and or if performance method, you probably aren't able to trade away from it these days with how the code is. So again, then it would be mandatory. And then coordinate with them to make sure that they get that quality HERS rater on board and that they go through all this with them. But otherwise, this is something we're seeing come up a lot, is the QII. I think it's because there's some lag time in jurisdictions, even though it's been required for a while. I get the feeling that now more jurisdictions are actually paying attention to this part of it. And it's going to show up on your HERS registry now that QII is required. So part of that process. So your authority having jurisdiction plans or building inspectors going to be looking for that on that HERS registry. When it comes to windows, because they're combining like all the types of windows you would have in a large multifamily project all under one big table, they've now looked at glazing fenestration by type and climate zone. So for example, you could have curtain wall, and you could have a special performance class window units, and by climate zone, those would have a requirement for the amount of fenestration or window to floor area ratio and a window to wall ratio. So we're probably used to seeing the window to wall ratio requirement in the non-residential, but now they've brought it into the multifamily. So you need to meet both the floor ratio and the window wall ratio. And if, for example, if you're going to have a curtain wall or storefront system on that high-rise res, then you need to make sure when you read this chart that you're looking to see is for your solar heat gain coefficient, is it a 3 or few habitable stories or 4 or more habitable stories? That'll inform you what you need. The maximum U factor, it just varies by climate zone, but not by height of the building. And then the kind of our common residential window, like you might see in low-rise residential projects of just that are a couple stories, that would be under your all other fenestration category. And that's also has a maximum U factor by climate zone. And then again, to look at 3 stories or 4 stories will determine the solar heat gain coefficient. And then say, for example, climate zone 5 and climate zone 6, if it's 3 stories or less, climate zone 5, there actually isn't a maximum solar heat gain coefficient determined. But once you go up to 4 stories, now you have to have a solar heat gain coefficient, or a calculated solar heat gain coefficient, including overhangs, if you go that route, of 0.23. And climate zone 6, they just said, doesn't matter how tall or short the building is, it's just 0.23 for the whole part of it. What it's going to look like, for example, on a prescriptive form, is that you're going to have your window and fenestration glazing. So you might call it typical window dwelling. You're just giving it a name at that point. And the type that you would look at in this case is an architectural window. It's operable, it's multifamily only, that part of it, but it's dwelling unit less than 3 stories. It's going to refer that the method they used was the table we just looked at, and it populates for you the maximum U factor and maximum solar heat gain coefficient. And then if the window unit you chose is less than that for both those values, then that window type is compliant prescriptively. And then if you were to use these prescriptive forms, it would go on to guide you through calculating those window to wall ratios and those window to floor ratios. And for exterior doors, same, there really isn't a big change other than now you've got dwelling unit entry doors with its requirement, common use non-swinging entry doors, and then common use swinging doors. So they all have slightly different values. You're allowed to have prescriptively by climate zone. And again, a lot of our projects go performance. So if they do that, these become the baselines that they're compared to. Okay, now we're going to hit a little bit on space conditioning dwelling units. Basically, heat pumps, for the most part, are prescriptive requirement, and they are, with the exception of climate zone 16, you could have a furnace for the small 3 stories or less. And so this changes the baseline, and the heat pumps do help with the compliance for the energy budget, both for source and TDB. So, it's like, okay, heat pumps, maybe that's what you're going to do. And sometimes because of other trade-offs, you need some more credits. So again, you get your HERS rater becomes involved with this on these, and you can get a performance credit for having all the ducts in conditioned space. And again, for you know, some of you that want to kind of improve your schematic design and what you're thinking about as an architect, these forms, just taking a look at them and kind of pulling up what's required can be helpful. This is an example on the right of how in this part of the project, they kind of dropped the wall plate in sort of the front of another portion of a wall that was soffitted into the other room, but they were able to get the ducts within the conditioned space. And they left space up at the top of the ducts so that the drywall could be taped for the ceiling to make a continuous air barrier so that there's space in there for the builder to actually work. So that was a good execution of how to get ducts in conditioned space. There's a very big credit available for variable capacity heat pump. And so what that typically means is that like your ductless heat pumps are often variable capacity. They'll meet these requirements. The fan doesn't continuously blow. And so in order to get that credit, then the indoor unit on that split heat pump needs to be part of the air barrier. So like wall mounted with the drywall behind the unit and everything is taped and sealed. And this does trigger a HERS workflow for it, but it's a good credit. And then what that can look like, because I know especially for our multifamily projects, we don't see that they want to have wall mounted heating and cooling systems. But ductless recess might be an option. And then architects, if that is something that is, you know, seems to be helpful for this project, just keep in mind that these units would still need to be within the air barrier. So you might have to create some details that address how that ceiling recessed unit would be part of a continuous and thermal boundary. But you get a good credit. You also you get good credits if you do the ERV and HRV. And so what I want to point out is that there's these prescriptive changes for these things. And this is a little bit more maybe where your mechanical engineer gets involved, and that just kind of FYI, these ERVs and HRVs have to have certain recovery efficiencies and fan efficiencies in order to be met prescriptively. And it varies whether it's 3 stories or less in climate zones 4 through 10, and then 4 stories or more in climate zones 1 and 2, and 11 through 16. So it's not each climate zone, and it depends on the story. So it's a little nuanced. So you would want to go into the code and take a look at that once you have that project. When it comes to the hot water, their individual dwelling units still can have heat pump water heaters or gas or propane instantaneous water heaters. Heat pump water heaters are also available for a central system. So that would be multiple units, more than 8 units on that system. There's prescriptive requirements for how you would comply with that type of system. And also multifamily projects still can have gas and propane domestic hot water central systems. So there's some kind of new requirements on some minimum thermal efficiencies for climate zones 1 through 9. And depending on the climate zone, the hot water heating system may have to have it would have to have prescriptively a solar thermal system with it. And what that kind of looks like in practical terms is if you're going to do individual dwelling units, water heaters, it's good to know this is kind of what the choices look like. And I'm pointing this out especially for the architects, because it may be that your client doesn't want to run natural gas to every apartment and save costs on that. And they aren't interested in a central water heating system, and they want each individual unit to have their own hot water. So then you could look at like this Sandon system. It's a split system. You need to know where's the outdoor compressor going to go. And it's a good practice to locate the water tank indoors in that case. And the tank in those types of systems have no moving parts, no refrigerant goes into the house, or the apartment. It's very quiet. So that could be a good solution. It just happens to be more expensive than the integrated heat pump type, where in a lot of cases for apartments, you would need to design that system so that it will fit. Is what we're finding is like the architect side of it is like, and real estate's valuable in multifamily projects. I mean, they are in single family, but even more so in multifamily. And so, get an idea about how much space that takes. And so what we have seen in some of our multifamily projects is a closet situation designed where they're able to install the tank. This particular multifamily project had taller than 8-foot plates, and they used a duct kit in order to accommodate that heat pump. And the reason for the duct kit is because these integrated heat pump water heaters take air, ambient air, they pull it into the unit through the top. And as that warm air runs through a fan coil and exchanges that heat into a refrigerant, it transfers that refrigerant, runs into the tank of water. No refrigerant mixes with the water, but it transfers that heat into the water. And then as a result, the air just had its heat pulled out of it. And so that air is now quite a bit colder, and it's going to come out dehumidified and cold. And so for a very small apartment, it may not be appropriate to have the cold air in the apartment year round. And so a duct kit might be the way to go. If you don't do a duct kit, that unit's going to need typically 750 to 1,000 cubic feet of volume available to it, which is also tricky for a lot of small apartments. They do give off noise. I mean, there is a fan and a compressor operating. It's usually around 50 decibels, which a lot of people don't mind, but some people think that's a bit too loud, especially if you're locating this near the bathroom, which tends to be near a bedroom. But in a small apartment, you can hear everything everywhere. So that's one of the things to kind of think about that in terms of clearances and space needed, and how you accommodate the ducts and just what that comfort level is. For central systems, we still, for the really big projects, sometimes going with a heat pump central system hasn't been making sense for some of our clients. And even though most of the apartment building is electric, they're still opting for gas boilers and loop tanks. And then now there's some new requirements for that. But we're finding that even for our projects that are going with lots of PVs and batteries, they're not wanting to do solar thermal water heating. And because of that, they're not using the prescriptive pathway for this type of heating system, and instead are going performance method. And then we trade off. We trade off the solar thermal and find kind of credits elsewhere. Now for heat pump, just committing to heat pump water heating systems, we're finding that a lot of our projects are doing that, and then they are just using the prescriptive pathway for the domestic hot water. And there are certain requirements that come with that, including, you know, the hot water return from the recirculation loop has to connect to a recirculation loop tank. That loop tank has to be electric if auxiliary heating is needed. If you've got a single pass primary heat pump, which is like the Sanco 2 is that type, then the thermal storage tank shall be plumbed in series if multiple tanks are used. And then there's some other requirements for set points and compressor cutoff. And we're seeing a variety of these systems being put together for multifamily. This is an example of a distributed Sanco 2 system for one of the projects we worked on. And for one portion of the project, it made sense to locate the Sanco 2 and tanks on the ground. And then for the other systems, they were roof mounted. And part of keeping the piping losses kind of under control is there is a variety of distributed rooftop systems, and then each of those accommodated a grouping of apartments. And just like those requirements in the other slide, we have a swing tank that's electric, and that's our temperature maintenance tank, and the return and the recirc is plumbed into that. We've got the single pass heat pumps, these Sanco 2 compressors, sometimes called condensers. They're set up in such a way that the water is single pass, goes through it, and then the storage tanks are plumbed in series. And the rooftop systems are set up similarly, but they're all set up on special platforms for sound isolation. And they have enough PVs to power what they need to produce the hot water. So overall, it's a good system for those folks. But we're seeing this type of system more and more.
Jennifer,
Yeah.
excuse me, we have a question from Julie.
Yes.
What are the minimum dimensions for the closet with a heat pump water heater and duct kit?
Minimum. If you want to make, okay, so the tank itself is a certain size. So depending on the size brand, you might, look it up. But just kind of rule of thumb, I've been telling folks like 30 inches by 36 inches, because a lot of times, like in that slide, accommodate expansion tank, the ducts, and a person needs to be able to get into the closet and actually do stuff. Like the maintenance person for the apartment building needs to be able to come by and change or clean the filter on the top of the heat pump unit, for example, or get in there. The plumber himself or herself needs to be able to get in there and actually do the work. And so that's kind of the minimum, is I'm telling folks. But technically, you could squeeze it in tighter, but I wouldn't. And some of it too depends on how you set it up, and whether it's a single door or double doors that open so you can really get to everything all at once. But about 30 by 36 inches is what I'd say. Okay.
Thanks.
Let's see. Moving along, this last part, solar PVs, battery energy storage systems. We get a lot of questions on this. So I'm going to give you hopefully some useful information, and then we'll close out with a bit of the highlights for additions, alterations. So just to be clear on kind of the requirements. So if it's a low-rise multifamily, 3 stories or less, you still have solar ready requirements. That's been a mandatory measure for a long time, but just remember that solar ready is triggered if PV is not installed, or the PV for some reason an exemption is not triggered. Then you have to make sure that your roof or the designated areas are solar ready. So in the future, solar can be added. Okay, so that's true for all the low-rise residential. The solar PV is required, and that's been a requirement for a while now for low-rise residential, and there are some exceptions. And battery energy storage systems, or batteries, BESS, that's optional. So there's credit available under the performance method. That's low-rise. So where you keep hearing, where we get a lot of questions, is then knowing, well, for high-rise multifamily, do I need to do a battery? BSS, yes, it's required when the solar PV is triggered. And solar PV is required for high-rise multifamily, but there are exceptions to that. And then solar ready, same idea, it's a mandatory measure. You only have to show you're solar ready if the PV wasn't triggered or installed. And that's true only for high-rise up to 10-story building. So if you have a 12-story building, the solar ready isn't triggered. And then just kind of FYI, we get this question a lot, asking to clarify battery ready requirements, because folks are hearing about battery ready, but that's only for single family occupancy types. So your low-rise multifamily battery, it's just an optional credit under the performance method. So solar photovoltaics, PVs for short, depends on, like we just discussed, whether you're 3 stories or 4 stories. It's going to determine how much PV you need. And then there's something called SARA, or solar access roof area. And that is any roof area that it can support PVs, where you have more 70% or more of the annual solar access is available to that part of the roof. And it can be on covered parking areas, carports, or new structures that you build on site. And for your PV system for less than 3 stories, I put the prescriptive formula here for you just to give you an idea of what that would look like. And it's based on conditioned floor area and an A factor, which is on a table next slide. It also varies with the number of dwelling units times a B factor, which is on the next slide. And then I calculated this out as an example for a project that's local in Pismo Beach, so that's climate zone 5. It had a conditioned floor area of just over 16,000, and there was 27 dwelling units. So calculate those numbers with the A and B factor from, I'll show you on the next slide, and ended up rounding up to needing a 38 kilowatt system. The other part of this calculation is if for some reason that Sarah was less than 80 square feet of contiguous space, no PVs required there. If you've got a snow load parameters you have to deal with, no PV. And also if it turned out that for some reason, miraculously, the PV size was less than 1.8 kilowatt DC, no PVs required. And then bonus, if you do install a battery, you can reduce that PV size by 25%. So that gives you an example of it. Here's those adjustment factors. And so as an architect, you could take a look at that kilowatt nominal size. You could reach out to a solar provider, or you could do some back of the envelope calculation on that nominal nameplate. Let's say you were working with a panel that produced 450, was rated as a 450 watt. You could look up the dimensions on that panel and take your size, divide by 450 watts to watts. So you could calculate how many panels you need. And again, if any of that, if you need help with that, there's some great examples in the energy code, in the manuals, also the blueprint. And you can give us a call on the Code Coach, and we'll help you calculate that and give you a rough idea of how many PVs you need. Similar concept for 4 stories or more, that you use a formula. The formula is a little different. You notice there's also a conditioned floor area times A, this A factor. It's a different table, not to be confused with the other formula. And here the PV is not required if the system ends up being less than 4 kilowatts DC nameplate. And then there's slightly different parameters on the Sarah, same with the snow loading, or the PV size equals 14 watts per square foot times that Sarah. So once you get to the high-rise residential, you'll want to have a good idea of what that Sarah is going to be, what part of the roof will actually have solar access. And then you can multiply it times 14 watts per square foot, and you choose the smaller of the two. And then I did a couple of examples here for a project using a project in San Jose that we worked on as an example. And then this A factor for the high rise, it changes by use type and by climate zone. And that will determine how many PVs you need. Gives you a good handle on it. The battery energy storage system, again, it applies to the high-rise residential as a requirement when PVs are required. And prescriptively, you would calculate an energy capacity and a power capacity. And you figure out what PV size you needed from the previous equation, from the previous example, and then determine, again, based on that use, you would multiply it by the B factor and that C factor for both the energy capacity and the power capacity. In this case, the D is a round trip efficiency. It has to do with the round trip efficiency on these. And those are the power ratio power factors. I will update the slide for your slide deck so that it's more clear on what that is. This is an example clipped from a cut sheet of a multifamily, or it could be a small commercial battery energy storage system, just to give you an idea of what this might look like. We've got a project that is currently pricing this out. And so instead of having like these individual Tesla batteries, like you might see for a single family home, what we're seeing on these larger multifamily projects, either for credit or because it's a requirement, they're having systems that include advanced demand controls, because you get extra credit for that in the performance method. And the system is all integrated to communicate with the cloud and include everything you need for doing either AC or DC coupling from your PV system into this battery system, and then working with your meter and your grid, and then your sub panels with all your loads for your multifamily housing. And then for those of you who are trying to get credit, your energy consultant can input the battery system into in this example, Energy Pro for the performance method, and the kinds of information they're going to want from you is, for example, does this battery system have advanced controls, advanced demand response controls? And there's some requirements that go with it, but it helps with the credit. And then they're going to need to know the energy capacity, which you get from the manufacturer. They'll need to know battery charge and discharge efficiencies and the rate of the charge and discharge. And then, of course, if it's a multifamily high rise, 3 stories or higher, then there are certain battery exceptions you can use. But in this case, we are looking at this specifically for the option of getting extra performance credit for a low-rise multifamily project. And the way this credit works is by climate zone. It'll take a portion of this and apply it to that efficiency TDR. Not a lot for certain climate zones, maybe 2-3% for our milder climate zones, but it can help. But for the colder climate zones, this credit could be useful. And then, of course, if it's high rise, you just are required. Okay, so we have just a little bit of time, and I'm gonna just real quick hit on some of these addition alteration changes just to kind of alert you to what you need to look at if you're working on additions and alterations. And this section, again, it's section 180, it's kind of divided up into additions, then the alterations, repairs, and the whole building. And it's nuanced. It's a nuanced section. So if you're truly working on additions or alterations or both and repairs, probably going to just need to go dig into the code altogether or work with your energy consultant on that. But some of the highlights is that climate zones 2 and 4, and 4 is where I am in in Atascadero up in San Luis Obispo, climate zone 9 in Ventura. Basically, those got an upgrade on roof and ceiling insulations to be R38. And additions for the ventilation, for indoor air quality, it depends on the type of addition you're doing. And there is just some clarification that junior ADUs don't trigger the IAQ. And a junior ADU means you perhaps had an existing large apartment, and that apartment had a portion of it now separated off, like a master bedroom, bathroom is now designed to have another person be there, but it's part of the same existing apartment. That doesn't trigger the IAQ. And then if you do an addition to one of the existing dwelling units itself, and it's less than or equal to 1,000 square feet, it doesn't trigger the IAQ. There's kind of a lot going on with alterations with the roofs, and whether or not you have to add exterior deck roof continuous insulation based on climate zone. So I just wanted to point out that those are requirements, but the things you need to take a look at and understand is what climate zone are you in, whether it's a steep roof or a low slope roof, and that this section is triggered when 50% or 2,000 square feet of the roof is being replaced, recovered. And it doesn't mean like a recoating if you don't touch anything else and you're just recoating it. That has to be done periodically. But if you're truly replacing it or recovering it with something new, then this triggers. Ceilings, again, vented attics. There's some, as we do remodels, the ceiling insulation's basically been upgraded in many of the climate zones to an R49 as opposed to the R30 or R38 in new construction. And that's because it's been shown to be a cost-effective way of improving the energy and thermal performance for those projects. And air sealing, it's always been required. However, there's a new section specifically for the alterations that addresses when air sealing must be done, and it's by climate zone. Not every climate zone has to do it, and there are some exceptions. So I wanted to point that out. So new construction, air sealing is always required, but now when you start altering stuff, you need to go back and air seal. Great resource is from the U.S. Department of Energy, and also HERS. Those HERS forms that we looked at also have great info on air sealing. There's been some updates if you're replacing or do a completely new duct system. So now it triggers at 25 feet of new duct extension. And it used to be 40 feet, for example. The duct leakage testing at 12% used to be 15%, for example. And then probably the other biggest thing is that just certain climate zones now have a duct insulation increase to R8 instead of R6. One of the installers I know just said that was too hard to remember which climate zone was which. So they're just using all our R8 everywhere. And you could specify that too and be safe. And next to last, if you're doing an alteration or replacement for heating systems, just kind of FYI, typically ductless electric heaters are not allowed, but there's some exceptions with alterations. If they already existed, you can go back to that, but it's a little nuanced. So if you really are determined to use electric resistance heating, I would take a look at this section. And alterations specifically are really trying to address now ventilation IAQ for those dwelling units. And it follows similar to the new construction where we talked about it, where you can now use ERVs, HRVs, add those to it. There's requirements for the kitchen exhaust, bathroom exhaust. There's just clarifying language. And so I would take a look at that section for sure if you're doing the alterations on the ventilation system. And then, you know, part of that whole design, the construction, the verification, it's a team sport, as we like to say. And more the HERS rater or your ATT needs to be involved with some of these projects so that you get good performance, but also there aren't any big surprises on the project for you. And what I recommend to the architects is that you include those HERS measures up front on the cover sheet. This particular sheet's for a single family house, but even on the multifamily projects, so, you know, you can't fit everything on the cover sheet. So, you know, highlight what you can, maybe push the index to all your plans on the second sheet so that that first sheet really it calls out if you're taking certain credits so that the builder is alerted to it and everyone's on board knowing that they need to get the HERS rater out there and that they need to make sure, especially if you're taking like a variable capacity heat pump credit, that they understand that equipment all has to be within an air sealed continuous air barrier, thermal barrier. And if you have more questions, call us or contact us online through the Code Coach. And with that, I'm going to hand it back over to Naomi to tell us a little bit about what's coming up. And thank you, everybody.
Yeah, thank you so much, Jennifer and Tatiana, for helping monitor the chat. So again, feel free to use the Energy Code Coach service. It's free and a great resource. Please contact me if you have any questions about education credits. And you will receive a copy of the slides, the recording, and the survey in your inbox soon. And I will go ahead and launch a poll that should be launched. If everyone could take that about the course today, that would be very appreciated. And please check out some of our upcoming courses. So these are a few that will be highlighted. Things like working with rebate and incentive programs for realtors, increasing referrals. There's a Cal Green Codes one coming up. And please visit 3cren.org/events for the full catalog of trainings for this quarter and the next quarter as well. And if there are any last minute questions, feel free to pop them in the chat if you have a couple more minutes, Jennifer.
Oh yeah, we do. If folks put it in the chat or even unmute yourself, and if you're able to unmute people on your end. Yeah, I'm happy to answer questions or stick around for a few minutes for sure. Oops. There we go. Back to that slide.
I think we might be all
I think
set.
I think I had another slide that was like the closing logo, and sorry.
Don't worry
I
about
clicked
it.
on that. It's like, so we'll leave it on this one, but yeah, great. Yeah, any more questions, comments, anything? Otherwise, I'll let you close out and be respectful of everyone's time. Do you see anything in the chat or? Okay.
Nope. So
Well,
I think
plus they're taking a poll and trying to chat, so.
yeah. Well, thank you so much for everyone for attending, and thanks again to Jennifer and Tatiana, and I will go ahead and stop recording now. Thank you so much, everyone, and have a great day.